And by the way, you realize that the exercise I'm giving you is the same as the one I had actually asked you to view online. The one for the fan not rotating, they are the same. But the fan rotating at a lower speed. The two things are actually exactly the same. They're not different. So I think let's have a look at what you guys were supposed to be handling. And then from there, you can do it on your own later. So as usual, we could just start a new project based on the Arduino here. And then I take the breadboard. And then I take the LCD display. And I can put it somewhere there because I require space for the temperature sensor, and our temperature sensor is given here. It's always like a transistor. We have it there. So I think that's fine. And the way I put it here, it should be okay. So we look at can get our LED, we can just place it already to make sure that we have placed all the components, and that is 220 ohms as we agreed. You can see we are really helped so much. I think somebody has done very excellent work in even putting the resistor to give us different resistances. I think these people, the individuals here have really helped us a lot because you can simulate all these devices, including transistors. So like the whole of electronics can actually be simulated as long as the components are available here. So then our connection, of course, will be, this is our ground. And this one, I think I'll just do it a bit faster so that you guys, I assume that you have already done it. So the VCC, then of course we agreed that the contrast goes to ground, and that will be black. Then the register select goes to 2, as we had agreed, to make it easier for us. And then of course the read write goes to ground also. And then enable goes to 3. Like that. And then we start with DB4. We agreed, I explained the reason why, all the way to the 4 and 7. So then we have 5. So pin 5 being connected to 5. Then we have pin 6 connected to 6. And in the actual case, that's what you're going to do actually. And then pin 7 connected to 7. And you also have our ground, our LED connected to 5. You can have it as red. And you realize that we have the temperature sensor, in which case we can actually decide to pick This is the power. It can go to 5 volts. I can either connect it down or I connect it up. So if I connect it up, then I'll just bring it here. And if I just want to use one wire, I just connect it there. So that will be red. And then if I want ground, I just connect it up here. And then bring it down here to just use one wire as well. That's black. And then this one is analog. So I just need to take it to an analog input, which is basically A0. And you can see there, don't have to change the color, reverse sun. Then from there, we power the system. So this will be a ground, which we can bring here. And just take it up there. So we have grounded the system. Then you connect 5 volts to the positive side. And this will be red. So the wiring of our system is basically done, the whole of it. We are left with only the programming part. So we program it so that we can be able to display the value. We go to program. So blocks, then text, then continue. And this one I can just remove the default program that is there. We don't need it. So then we check the library. So we have include, and of course we want to include the liquid crystal. Crystal, I like using the dots. I think themes. Then the liquid crystal, just copy it because you already have it. Then you put it down here, and it's LCD. And we know we are dealing with pins 2, 3, 4, 5, 6, and 7. Then you have closed. And of course, inside here, I want to have LCD.begin to start it, to initialize it, and we are dealing with 16,2. I think we are done with that one. Now we need to read the temperature, but we also need to declare the analog inputs. So in this case, we are going to do pin mode. I think that's what maybe we have, but I think we did this, so it's not supposed to be a big problem. So pin mode, and I have A0 as input. So that's our inputs. And I think we are just going to display on the LCD, so we don't require the serial monitor. So in that case, then we read the value int A is equals to analog grid, because our temperature value will basically be given by the analog sensing, which are connected to A0 here. So we need to read it, and we read it from A0 like that. And after you read, you store it in A. That's what you have done. Then before you even use it, you can try to see whether it can be displayed that value. So we can do LCD.print. We see whether it prints it first. Then, of course, we are going to, first of all, before we print, we can set the cursor. LCD dot set your cursor. And, I will set it at 0, 0. Then LCD dot print A. Sometimes you can print A is equals to, no problem. I think we can just be able to do that actually. We can say LCD dot print before we do the A, we can print temperature, the word itself, temperature, we can say sensed temperature. How many are these? 1, 2, 3, 4, 5, 6, 7, 8, 9. They are beyond. So sensed temp. Let's just call it sensed value because we have not. We need to convert it to temperature. So let's just first of all do sensed value. Is how many are these? 1, 2, 3, 4, 5, 6, 7. That will fit. So sensed value, and then of course we can print it. I believe we could print at the end. Sensed value is I can print this at the end. So still the same column, but I'm looking at maybe the same row, but I'm looking at maybe 14 or 13 there. 1, 2, 3, 4, 5, 6, which means that's 12. 6 is actually 11 because of 0 up to 11. Eh? And then it starts printing now the value. Let's see, sensed value. Let's see whether it prints it. So that's our sensed value. Let's see what it gives us. So if you look at what we are displaying on the screen, you look at it clearly, you will see 358 as the maximum, that 358. And I'm also seeing 209 as the minimum, which corresponds to 40 degrees C, and the other one corresponds to 125 degrees C. You can actually map the value. So the sensed value is given by that, but that's not temperature. Temperature in itself is 40 to 125. So what do you do? We have seen the values 125 corresponds to 358, and 40 corresponds, is that 40 or negative 40? Okay, I can't see. I think it's negative 40, the maximum. The minimum is negative 40, not 40. It's actually negative 40, corresponding to 2 or 3. You could even decide to have your own values, 2 or 3, and 358 are the values that we are reading. Just correspond to them. And to correspond to them to whatever you want, you map. So I might not be printing out that value. I would want to print temperature, and in that case, then I will say temperature. Temperature is so. This is 1, 2, 3, 4, 5, 6. It goes up to 7. Let me see what it gives me.
Hello?
It overlaps, so please put off your microphone when you're talking. So it overlaps, so we need to do something. Maybe I can just do it that way. Temperature. Or we can say temp is, this still will be fine. I think we can start from 12, so that maybe the last one we can indicate degrees. But I'm going to map this value. So this is how we're going to map it. You do int b is equals to map remember so I think I will sort out that. Then I'm just mapping the value so that we can get some temperature, and I want us to range, it was 203 to 358. So 203 to 358. You map A, comma, 203, comma, 358, comma. So we have, I can range it from 20, comma, to maybe, to, let's have like, let's have 100, because maybe it's a heater somewhere which can heat up to 100. So we map it that way. Then this time I'm going to print the value of B, not A. Let's see how it does it. Temperature is -5. So 2 or 3, we didn't get this correctly maybe. So -674. What I was reading. So 358, 200. Unless it behaves funnily, let's have that 200. We see what it does. Still give me negative values. So -40, 200. And gives -74, 71. So I'm thinking it's not mapping this properly. Let me see whether I will manage it properly. So this thing is is giving corrupted values. They are not exactly what you expect to get. You can see it reaches a point, it increases, it reaches a point, it reduces. So let's get up to this point here. Before it starts increasing again. So I think the issue could be the value that you have put here. Let's try to have this as instead of the integer, we can do double, we see what it gives us. So that it can give us the correct values. Yeah, that's 20. That's 258. 20, 258, 358, 20 and 358. Let's see whether this time it gives us something correct. So between 20 and 358, then 20 and 100. And we have this as B. So you can see it gives us 20, then we have 100. So those points now, you don't need to worry about them. I think we can be able to change so that it can display those points in a way. So we start maybe like printing at 11. That way, most probably, I believe we can be able to get everything printed properly with one decimal point or two decimal points. So if we go maximum, it's 100.0. If we go minimum, it's 20. And I think the mapping is now correct. So from that mapping, let's try and see how we can do the ranges. How do we do the ranges? Between 20 and 40, it's normal. So we can do this from this point. So we say if, we do the if statement, if B is less than 40, if B is less than 40, then of course in the second column we print something, set the cursor. Please note that I'm just giving an example. This is not an exact value. There is a way you can use this sensor to do exact values. But me, I'm just giving you an example so that you can be able to see on how you handle these things. It's just a general case I'm picking. It's not an exact representation of what we have here. So I'm printing in the second row, and I'll print temperature is normal. So temperature, normal. This is, let's see whether it is normal, whether it does more. So this is 1, 2, 3, 4, 5, 6, 7. It will print. So then the other one is else if B is greater than 40. There 40 is not included actually. So if B is greater than 40, is greater than, maybe you can do that 9, no problem. And B is less than 60. Then we are going to print temperature. Temperature above normal. Temperature, we can say temperature high. Because above normal, I think it might not fit. So temperature is high. Then we do else. And you print here. Temperature too high. And of course, if you want to scroll the word that we had, you can be able to do it. Then you need to make sure, I think you put these ones in brackets so that it accepts, since we have more than one line. And then let's see what it does. So the temperature there is high. Temperature is normal. Up to 20. And then temperature is too high. So what's happening? Sometimes you need to clear. Like now, if you see one of them is giving us error is also appearing. So you can clear the LCD at this point. So LCD, you can do a delay. Usually a delay is important so that you can be able to see something. 1000, and then you do LCD dot clear. So please, you can be putting up your name, your registration numbers, name. So I think if you do it that way, then what we had in the third one does not appear. So let's go to high, temperature too high. That is 79 up to 100. That will be from 60 onwards. The temperature will be too high. That's what it will indicate. Yeah, so please, I will expect you to put up your registration numbers. Then you can be able to do exactly what I've done later. If you would want to print degrees, you can also put degrees here. So, like now, I can actually put degrees, and this is what you do. You can put degrees here. And I don't know whether it will be able to fit. Let's push this one a bit and have it at maybe 9. 1, 2, 3, 4. That's okay. Then degrees start from 12. Let's see what this one gives us. Because of the double, can have this as 8, and then this as 13, 14, 15 is enough. We'd want to, like, those spaces are enough, so I think that's what you can be able to do, though you realize that there's no space between the value and the degrees. You can change that. And I think that's an overview of what you can do. Please know that you can be able to calibrate this from the actual values that we have inside here. And then even the programming that we have done, you can change a few things here and there so that they fit what you want them to fit. So, and I think that's what I wanted you to check. We do, and I think none of you said you have done this. And you see, this is what even they have done in that pro. Please note that what I gave you as a screenshot, it's what happened with my mobile phone when I was relaxing out there. I had a case where the temperature was too high. Then it showed me that. Then I took an image because there's a course I usually take on computer maintenance. I actually gave an exam based on the same. It's the same thing that you can actually be able to do with this mobile phone. You can see much of what you even do out there. Radios that we have in terms of radio defined, the software defined radios. Please note that much of the things are transformed, of the operations are transformed into software, and then you just see the display and the input. The sensors and actuators are the ones that you manipulate around, but the operations are usually done inside the processor. I think that's good. One project I would want to do is to have a radio, which is software completely. Then I have the knobs rotating and also the display showing me, and it does the FM. I think if I can do that in software, I can be very happy at one given time. So one of the projects I would want to work with when I'm teaching signals and communication, maybe in terms of the receivers, we just implement it in software. After all, of late, most of the things are going software with the ones which you cannot change to hardware only, like the sensors and actuators. I think that is what I wanted you guys to do for today. Otherwise, we can meet next time to continue. But I will post this up. And if you have a question, you can also ask maybe even through the class rep so that I can be able to answer that. But otherwise, you guys bye and see you next week.